have a word problem. A rambler start a walk at the bottom of the hill at 10 a.m. So at the bottom of the hill at 10 a.m. and then he goes up to the top and then turns around and walk back down. This differential equation used to model the vertical displacement, that is our x, vertical displacement in meter. And then T is time taken in hours. Now, given that after 1 hour, the rambler has a vertical displacement of 213 and the x dt of 273.2. So, T is equal to 1, x is equal to 213, dx dt is equal to 273.2. Question A. Determine the value of A to 3 significant figures. We just have to substitute all three values t, x, and dx dt into our differential equation. So it will be sine 1 times 273.2 minus 213 cos 1 equal to A sine 2 sine 1. Let's plug this into our calculator. Sine 1 times 273.2 minus 213 cos 1 alpha equal alpha A sine 2 times sine 1. So shift solve for A equal. So A is equal to 150.04. We want it to be only up until 3SF, so A is 150. For B, hence determine the particular solution of this differential equation giving in this form. Okay, let's write down our differential equation. Sine t dx dt minus x cos t equal to 150 sine 2t sine t. Now we have our DE. We want to rewrite this in standard linear form. Standard linear looks like this. Okay, dx dt plus ptx equal to qt. Notice that we don't want to have sine t in front of that. So what we're going to do, we're going to divide everything by sine t. Okay, we will get dx dt minus cos t over sine tx equal to 150 sine 2t. This sine t will cancel with this sine t. Why do we write in this form? Because it is easier for us to find the integrating factor. And what is our integrating factor? Integrating factor is e to the power of integral pt dt. Include the negative. This is our pt. Integrating factor is equal to e. Integrate negative cos t over sine t dt. How can we integrate this? Let's use substitution method. Let u equal to sine t. Therefore, du dt is equal to cos t. dt is equal to du over cos t. This one would be equal to e negative cos t over u du over cos t. So we can cancel this, and we will get e integration of negative 1 over u du, which is equal to e negative ln u. Let's now substitute back our u. We will get e negative ln sine t. Okay, let's bring the negative up. We will get e ln sine t, the whole thing, -1. We can now cancel the e and ln. So we will get integrating factor equal to sine t -1 or 1 over sine t. Now we have our integrating factor. What we will do next is we will multiply, okay, this equation by our integrating factor, which is 1 over sine t. We will get 1 over sine t dx dt minus cos t sine squared t x equal to 150 sine 2t over sine t. Okay. Now, what we have on our left hand side is actually an expansion of product rule. Here is our u and here is our dv dt. Here is our du dt and here is our v. So we have plus here. So this is product rule. This is equal to d dt u multiplied by v. Okay, so I'm going to put this at the top here. So this is what we have on our left hand side. Left hand side would be d dt u. What is our u? U is 1 over sine t multiplied by v. What is our v? Our v is x equal to 150 sine 2t over sine t. What we're going to do next is we will integrate both sides. So integrate dt. Integrate dt. For our left hand side, this is quite straightforward. Integration and d dt will cancel each other. So we will get 1 over sine t x equal to 150 over sine t. Now we can expand sine 2t. Sine 2t is actually equal to 2 sine t cos t. We still have to do the integration. Okay. So we'll cancel this sine t and we'll get integration of 300 cos t dt. So this is equal to 300 sine t plus c x over sine t. Let's now substitute the values that we know. We will let t equals to 1 and x equal to, what is it? 213. So 213 over sine 1 equal to 300 sine 1 plus c. Okay, let's use our calculator. AC 213 over sine 1. Alpha equal 300. Okay, alpha equal 300 sine 1 plus alpha c. Now shift solve. Oh, error. Let's see. Oh, we don't have. Let's close this. Okay, that's it. Shift solve. C is equal to 0.687. 3 significant figures. So x over sine t is equal to 300 sine t plus 0.687. I would like to multiply everything by sine t because we want to leave our answer with x as the subject formula. So we'll get 300 sine squared t plus 0.687 sine t. Done with part B. Moving on to part C. Use the model to determine the time which the Rambler will return to the bottom of the hill. So bottom of the hill, that means x is equal to 0. So 300 sine squared t plus 0.687 sine t equal to 0. Let's factor out sine t. So 300 sine t plus 0.687 equal to 0. So we have sine t equal to 0. Sine t equal to negative 0.687 over 300. From here, we will get two answers, t equal to 0 and t is equals to pi. So this is when you go up, so you will reject. So this is the beginning. So this might be it. Okay, let's take a look at the second part. We have a negative answer. So this one would be in the third quadrant. So your t would be pi plus inverse sine 0.687 over 300. So it will be more than pi. So we will reject this as well. The Rambler only go down once, so we should take the first value, which is pi. So t is equals to pi, which is equal to 3.141. If we write it in hour and minute, it would be 3 hours 8 minutes. It would be times is equal to 10 plus 0308. That would be 1308, or we can write it as 1:08 p.m. Moving on to D. Given that the vertical displacement of the top of the hill is 300.68, use the model to find the value of t when the Rambler reached the top of the hill. We have, okay, x is equal to 300.68. So our equation would be 300 sine squared t plus 0.687 sine t equal to 300.68. Let's bring everything to one side. So we'll get 300 sine squared t plus 0.687 sine t minus 300.68 equal to 0. Menu, equation, polynomial, degree 2, 300.687, negative 300.68. Okay, the first value is, I would say, 0.999988. And the other one is t is equal to negative 1.00227. So this one would be sine t and this one would be sine t. But the second value would be rejected because it's more than 1. So now we want to find the value of t. So it would be inverse sine 0.999988. There we go. Menu 1. So shift sine 0.999988. T is equal to 1.57 to 3 significant figures. Let's take a look at the last answer. Using your answers to part C and D, give a limitation to the model. So this model assumes that the time taken to go up and down are the same. In reality, it will be different.